Hi, Math 1103 students. Welcome back to this session. And this session will be over Chapter 3. This will be a lot of reading and comprehending. We will not have a lot of calculations, so it'll be very interesting, but very exciting. It deals with statements, negations, and quantified statements. A statement is a sentence that is either true or false, but neither both simultaneously. Examples of statements are London is the capital of England. William Shakespeare wrote the television series Modern Family. Some examples of sentences that are not statements are commands, questions, and opinions. They are not statements because they are neither true or false. Examples are Titanic is the greatest movie of all time, which is an opinion. Read pages 23 through 57. That is an order or command. If I start losing my memory, how will I know? That is a question. Using symbols to represent statements. In symbolic logic, we use lowercase letters such as P, Q, R, and S to represent statements. Here are two examples. London is the capital of England. That could be represented by P. Q can be used to represent the statement William Shakespeare wrote the television series Modern Family. The letter P represents the first statement. The letter Q represents the second statement. The negation of a true statement is a false statement, and the negation of a false statement is a true statement. Negation just means the opposite, not. That formed the negation of each statement. Shakespeare wrote the television series Modern Family. So a negation could be Shakespeare did not write the TV series Modern Family, or it is not true that Shakespeare wrote the TV series Modern Family. So I'm going to go with the first one. Shakespeare, excuse that cursive writing there, but it's less clicks when I write cursive. Did not write, I'm going to put TV series Modern Family. All right, B. Today is not Monday. So if you negate that, you can say today is Monday. Or you can say it is not true that today is not Monday. Let P and Q represent the following statements. Shakespeare wrote the television series Modern Family. For Q, today is not Monday. So now we're going to express symbolically with the P's and the Q's. So Shakespeare did not write the television series Modern Family. That will be notated as a squiggly line P. Today is Monday. That will be a squiggly line Q because that's the opposite of not. Section 3.2, compound statements and connective objectives. Simple statements convey one idea with no connecting words. Compound statements combine two or more simple statements using connectives. Some examples are and, or, if, then, and if and only if. And statements. If P and Q are two simple statements, then the compound statement P and Q symbolized by this symbol here. I call it like a half of an A, or just rooftop, like the power carrying calculator. The compound statement formed by connecting statements, the word and here. Now we have let P and Q represent the following simple statements. P, it is after 5 p.m. Q, they are working. So we write it in symbolic form. We want it is after 5 p.m. and, so all you need is the and symbol, and they are working. So this is a symbolic form. And again, if I'm going too fast, you are welcome to stop, pause, rewind, fast forward, whatever you need to do. It is after 5 p.m. and, so you have the and symbol, they are not working. So therefore, you have to put the squiggly line in front of the Q because it's not. And now here is a chart with just different various words. Instead of and, you can use and, but, yet, nevertheless. For example, it is after 5 p.m., yet they are working. It is after 5 p.m., nevertheless they are working. So these are different connection words for and. Disjunction. Disjunction is a compound statement formed using the inclusive or represented by the symbol color V because it's or. So we're going down for or. So if it's not making the A, then you know it's the or. Let P and Q represent the following simple statements. P, the bill receives majority approval. Q, the bill becomes law. So we want to write this in symbolic form. We're going to use or. So the bill receives majority approval, that's P, or, so we use the V, becomes law, Q. The bill becomes majority approval, that's the P, then we have the word or. The bill does not become law, so we put squiggly line in front of Q. If-then statements. If P, then Q. This is called a conditional statement. The statement before the arrow is called the antecedent. The statement after is called the consequence. Consequence. Let P and Q represent the following simple statements. A person is a father. A person is a male. So if a person is a father, then that person is a male. Therefore, we have the arrow for implies. All right, if you let P and Q represent the following statement, a person is a father, a person is a male. So we put it together and we negate them. If a person is not a male, then the person is not a father. All right, if and only if. Biconditional. So if you're talking about if and if, only if, that's the biconditional. And it has a symbol here with the two arrows. So biconditional statements are conditional statements that are true if the statement is still true when the antecedent and the consequence are reversed. So let's see. If we reverse it, if a person is a father, then the person is a male. That's true. If a person is male, then the person is a father. Not necessarily true. So we can't do an if and only if with that. So here, a person is an unmarried male, then that person is a bachelor. If a person is a bachelor, then that person is an unmarried male. So this one can be combined with if and only if. A person is an unmarried person if and only if that person is a bachelor. Well, should be unmarried male. So if and only if, you will have the two arrows. And now this next page is just kind of putting it together page, not P. This is the and this is the or. So you do have to get familiar with these and know these. This is if, comma, then, and this is if and only if. Now we're coming to the truth tables. Truth tables are exciting. They encourage you to think and stay focused on what you're doing. Many of you have not seen a truth table, but it's really okay. We're going to make it. All right, so the negation is not opposite of the truth table from the statement. So just say somebody's making a table, they give you the P. This is the hypotenuse. So if they say not P in this column, so if you have true, what's the opposite of true? False. If you have false, what's the opposite of false? True. So that's what we're going to do back and forth with the different truth tables. All right, so here if you have and. So I want you to remember something. If it's true and true, think about it. If it is Let's see. The ice cream is cold and good. So you know that is true. So if the ice cream is cold, not good, then that's overall false. And then if something is false and true, that's false. If something is false and false, that's false. So basically, for something to be true, the and symbol, that's these. It's on your fun fact sheet too, I believe. You would need to have true, true, and true all across the board, just true. Because think about it, if you tell the story like once or twice, then it's not true. Anything that you put in the mix that's not true will make that false. All right, so now we're going to look at or. So we say, okay, you got to choose between the truth or the fiction, then it'll be overall not true. So be overall true. And kind of like true trumps everything. So if you got true or false, then it's true. If it's false or true, then it's true. If it's false or false, then it's overall false. So in order, if you're dealing with the word or, everything is true because if you got one truth, then it's like, okay, this is true. So this is really false if you have all false. So if it's like this or that, it's going to be true. But if it's all false, then it has no other choice but to be false. All right, so P and Q represent the following statements. 10 is greater than 4. Yes, that's true. 3 is less than 5. Yes, that's true. So let's look at this, P. So if 10 is greater than 4, and you got to put and with this, and 3 is less than 5, then basically what? This is truth, and this is true. So if you're dealing with and, since they're both true, then your overall answer would be true. All right, if it's not true, so that means the P right here. So that means if this is false, and then this is the or, true. Remember we said if it's false or true, then, oh no, this is and. I'm sorry, it should be and. If something is false and true, then hey, you telling the story, you can't tell false truth, then tell the real truth. So this is overall false. Because P is true, and then if you negated that, it will be false. All right, so false and true equals false. All right, so we look down here at the bottom. And it's kind of hard to look at the values. It is easier with the words, just the letters. But it's okay. So now we got P, which is 10 is greater than that. So this is true. And then this is an or. So will this be true or, and then 3 is less than 5. They said they want that to be false. So that will be, because you have to negate it, true or false. So that will be, if it's true or false. Because if it's true, when you're dealing with the or, if you have one truth, then it's true. But if you got F or F, then it's false. All right, so this one will be false. And then this is or false because we know that we can't, that is correct. So if they're both false or false, then it is false. All right, the truth tables. And you have an awesome amount of homework with it. Okay, so we say, basically if you got the truth table, and this is the and. Remember, when you're dealing with the and, for the only time it's going to be true is if you have all truths. So that's that. If you have both truths, then you know it's truth. Everything else is false. Because if it's true and false, then it's false. If it's false and true, that's false. If it's false and false, it's definitely false. All right, so we fill in this chart. This is and. So we already looked at up here above. It was true and true. This is true. Now this squiggly means just do the opposite of whatever this second column is. So the opposite of true is false. Now if you got something true and false, then remember we said that's false. This is and. So we know basically all of these are false. But if now we do the opposite because of this symbol, the opposite of false would be true, true, and true. So it's really pretty cool. It's really fun when you sit there and just take your time and go through it. All right, the last truth table. We're going to do the opposite of P. So I'm only going to look right here, the opposite of true. This is going to be false. This is false. This is going to be true. You only look at one letter. I only looked at this P column for this one. So now I'm going to do, this is or. So I'm going to look at this column right here and this column. So I'm going to say this or this. So if it's false or true, then it would have to, if it's false or true, then it has to be true because that's for the or. You saw it has to be true. All right, so this is or 2. So if this is false or false, then it's absolutely false. If it's true or true, then it has to be true. Then if it's true or false, then it has to be true. Truth trumps it. All right, so for not Q, that means this is the opposite of not Q. So this is our Q category. So the opposite of not Q would be, opposite of true would be false. Opposite of false would be true. Opposite of true would be false. And the opposite of Q would be true. So now for this column, we're going to put everything together. This column, which is this column right here, that's the first part. And then it's going to be and this second part. So for the first one, if I have true and false, if something is true and false, then it is false. All right, so right here, if something is false and true, then it is false. Because remember, and we only want all truths. If it is true and false, then it's false. If it's true and true, then this is true. So the F's and T's may look confusing, but if you sit and think about something is true and false, or if it's true or false, is it really true? Is it really false? Just think about the overall meaning. So again, a great thinking course for you. Great. I'll see you back with chapter 6.